So we'll start this video just with a quick review. The question that we asked last week before the long break, will any three segments make a triangle? So does it really matter what these different sides are? And the answer to that is yes, the sides do matter. So will any three segments make a triangle? No. And remember, what we found was that, let's say the base of this triangle is 10, the other two sides, the two smaller sides, have to be, when we sum them together, must sum to be bigger than 10. So there's a lot of options out there. All right, so if that's 5, remember we want something 5 plus whatever this is to be bigger than 10. So, maybe a 6 would work, or potentially 7. So kind of the trick that we did, all of a sudden I started giving you some side links. Will the sides 2, 3, 4 make a triangle? And so we would check. The two smaller sides in this case would be 2 and 3. So 2 plus 3, is that bigger than 4? And sure enough, 2 plus 3 is 5, and 5 is bigger than 4. So yes, that makes a triangle. Maybe I give you the sides 5, 6, and 11. Will those make a triangle? So let's say that's example 1, this is example 2. Well, again, let's take the two smallest sides, 5 and 6. So 5 plus 6 equals 11. 11 is not bigger than 11, so in this case, it will not make a triangle. So we'll take a quick second. We'll practice a few of those on your own. And then one of the extensions of that is all of a sudden if I tell you that if you're given two sides, find the third. And really it's find possible links of the third. And we did a little bit of some exploration with this. But there was a really easy trick once we kind of explored. So let's say that the sides I give you are 3, 6, and we don't know the other side. Well, there's a lot of options that we can plug in here, and the real easy way to do it, we had this inequality that we would set up, this compound inequality with x in the middle. And the real easy way to do this was you find the difference between the two given sides, and you put that at the beginning of the inequality, and then you find the sum of the two. So in other words, well, 6 minus 3 equals 3, and then 6 plus 3 is 9. So any side that you pick between 3 and 9 would work. So for example, you could plug in 4. So 3, 6, 4. Does that make a triangle? Well, the two smallest sides, 3 and 4. So 3 plus 4 is 7, which is bigger than 6. So yes, that's a triangle. And then so on and so forth, right? The number 8.5. What if we tried 8.5? That's between 3 and 9. So 3, 6, 8.5. Well, this time 3 and 6 are the smallest sides. So 3 plus 6 equals 9, and 9 is bigger than 8.5. So that makes a triangle. So there's an infinite number of these things. So remember, the best way to do it is to do this difference followed by the sum. So one more quick example. If I give you the sides 5, 6, and x, we don't know that third side. So again, x is going to be this inequality, so subtract the 2. 6 minus 5 is 1. And then add the 2. 6 plus 5 is 11. And any value between 1 and 11 will give you a triangle. So moving forward, what we want to look at is Pythagorean Theorem. This is nothing new to you guys, but just a quick reminder, I guess, for the first part of this lesson. Remember, a right triangle has a right angle. And there's basically two parts. The side across from the right angle is called the hypotenuse. And then the other two sides, we've talked about this before, are called the legs. So a lot of times what you guys are probably very, very familiar with a Pythagorean theorem is a squared plus b squared equals c squared. And that's where we put a and b on the two legs, and then c is the hypotenuse. Another way you can look at this, if you just do leg squared plus leg squared equals hypotenuse squared, that's another way that I've seen this written quite a bit. And so the hypotenuse, again, is across from the right angle, and then the legs are the two sides that touch the right angle. So just a quick rundown. So label the hypotenuse with the letter C. All right, so here's the right angle, so go across from it. There's C. Here's the right angle, go across from it. Notice C never actually touches the right angle. It's always across from it. So those are all your hypotenuse. And so when you're solving some of these, not sure what that blue line is in the middle of the page, but um, what we need to take a look at, well, I'll just go ahead and put an X on the missing side. So right now we're missing a leg. So what we have, 9 squared plus x squared equals 15 squared in this particular case. So it's just working our way through this. So 9 squared is 81. 15 squared is 225. And so we'll subtract 81 from both sides. So x squared equals 4, 8, that'd be 144. And if we take the square root, x equals 12. So the missing side here is 12. And then another example, now all of a sudden what's missing happens to be the hypotenuse, right? So in example 1, there's the right angle, x is right next to it, so I was missing a leg. Now all of a sudden I'm missing the hypotenuse, so again, I'm going to just plug into that. So this is a leg, this is a leg, so leg squared plus leg squared equals hypotenuse squared. So 36 plus 4 equals x squared, which means 40 equals x squared, and then x will just be the square root of 40, and you can plug that into your calculator if you'd like. So try a couple quick examples on your own. If you'll look at 1 and 2, and then I'll ask you to go ahead and plug those into the video here in just a second. And then finally, the converse of the Pythagorean theorem. This is probably something that might be new to you. And we talked about this a little bit last week. When I just give you 3 sides of a triangle, it's very easy to see. So for example, look down here at number 9. This is definitely a scalene triangle. We can see that because none of the sides are equal. But we couldn't go so far as to say, hey, that's obtuse, that's acute, that's a right triangle. We couldn't classify it by angles until today. And so what we can do is actually use the Pythagorean theorem in order to do that. And so the big thing that we want to do starts with the biggest side. If you'll remember to always put the biggest side first, then the inequalities that we're about to set up will set you in a position where you're going to know what to do. So first off, a right triangle, biggest side, which is called the hypotenuse, equals small squared plus small squared. If it's an acute triangle, we want big squared, and it's going to be less than small squared plus small squared. I'm getting away from a and b squared just because we don't know if it's a right triangle all of a sudden. And then obtuse, again, we're going to square the biggest side, and we're going to square both the smaller sides and add them together. But this time, the biggest is going to be greater than. So what we're letting, by doing the big side first, we're then, the inequality is basically going to tell us what's happening. Less than seems like it goes really well with acute. Greater than just kind of falls in line with obtuse. So what we can now do is take a look at this particular example. So the biggest side here is 41. So we'll compare 41 squared and the two small sides, 9 squared plus 40 squared. So if you take a moment, we'll do some quick calculations on that. So 41 squared equals 1681. And then we got 81 plus 1600, which sure enough is 1681, and those two things are equal, which means this is a right triangle. So not only is it isosceles, now we can say it's right. So 6, 7, 8, find the biggest side. There it is at 8. So we'll do that one first, right? Biggest side first. So 8 squared. We're going to compare that to 6 squared plus 7 squared. Make sure you square them before you add. So 64. Now we got 36 plus 49, and that is 85. And here, 85 is bigger than 64, but that less than, right? 64 is less than 85. Less than goes really, really well with the idea of an acute triangle. And so that one is acute. We'll try one more here on the video. So the biggest side here is 17. So we'll go 17 squared. And we're going to compare that to 16 squared plus 3 squared. So 17 squared is 289. And then 16 squared plus 3 squared is 265. And here the 289 is bigger than. And since we're bigger than, it falls very well with obtuse. So take a second and try 4 and 5 on your own. And then as you finish this, flip over to page 7, and that'll be your homework for tonight.